A very good day to my lecturer, Madam Fiza, and my fellow group mates. My name is Garizo Balwan. My matrix number is TB23018. In this project, I would like to present about implementation with commercial components. First up is why the reasoning behind choosing the specific components. It's like what's the reason why we need to choose the component to make it into a demodulated circuit or demodulated waveform? Okay, the first component is 1BH62 diode, available to handle the carrier frequency in the range of 10 kHz. It had reduced forward the voltage loss to improve the signal detection. For minimized distortion, the diode possesses a high frequency response. Second up component is rated coupling capacitor. It can block a DC components while pass by alternative current signal. The maximum enough required to pass the message frequency is at least 1 kHz. Okay, last but not least, the the next component are resistor. The resistor had a proper load for detector in parallel connection. The value chosen to give a diode enough current to function. And B is maintain an appropriate output voltage level. Okay, now that is for the reasoning. Now the next up is necessary operating details of selected component. The What's the features behind when choosing the component? Let's start with diode 1BH62. The diode has forward voltage of 0.7 volt and a maximum voltage range of 85 to 90 voltage, and it has fast switching speed appropriate for 10 kilohertz carriers. Second is rated coupling capacitor. It has a supply of 12 volt rating voltage. It it's stable because it is a non-conductive material and has a low leakage current. Okay, next up is a resistor. The resistor we choose because it's a low noise and the power sufficient is a quarter. Okay, here is my implementation diagram using the selected component. Let me just zoom in so we have a proper clear pictures. Okay, it's something like this. It input AM signal to enter through this capacitor, then to enter through this diode, then after diode to enter this capacitor again, and go to the resistor so we can uh, generate output demodulated signal. And here's what kind of symbol of the component. This is a capacitor symbol, this is a diode symbol, and lastly this is a resistor symbol. And I want to go to the multisim. Okay, this is what the modulator looks like, modulator circuit look like, the original. And what we're gonna modify is with this circuit, we got this capacitor, we got this diode, we got this resistor connected in parallel, and this lastly is this capacitor also connected in diode. Then we modify like this. So if we become like something like this, then we can generate the amplitude demodulation. So that is all from me. Thank you very much.
Assalamualaikum warahmatullahi wabarakatuh. My name is Haris Sharafin Karudin. My ID number is TB23044. So today I will present about simulation for project AM Demodulator. So basically this is we have combined another group for AM Demodulator and modulator. So basically what we use component here is first is the signal and the voice. For signal we set to 50 VPK and 10 kilohertz, and for voice we set to VPK and 1 kilohertz. And also we use BC 107 BP. Okay, let's try our output for this project AM Demodulator. So Basically, we run first. Let's see. So as we can see here, this is our graph or waveform from oscilloscope from our combined circuit. So what we got here is this is a carrier frequency. That is this is what we got on Demodulator from the lab. So we got the same like this, and in pro in another one we also get similar like this. That's all from me. Thank you.
Okay, Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amani Hakim, student TB23046. I'm the last presenter for our group. Our group made the AM Demodulator project, and the final result of it is proof by the hardware implementation that we do in the lab with other groups that they design the modulator for our demodulator. In conclusion, the AM Demodulator project effectively proved that the experimental outcome matched theoretical prediction, and it's confirmed of the system that we designed efficient. The accuracy of the circuit implementation and the fundamental idea of amplitude modulation and demodulation were confirmed by the demodulated signal that we got by designing the hardware. So overall, the project achieved its objective, but it can be more improved with multiple solution and recommendation, such as generate a more stable carrier frequency by using crystal oscillator, use multiple diode to achieve a better signal in demodulation process. And also we can select the component for our circuit design uh, properly and more better. The next is the experiment and hardware part. For the first figure, this is the figure of our demodulator circuit that we construct on the breadboard. As you can see, this for the input that come from the modulator, and this is the ground. This line right here is the ground terminal. Okay, for the next figure, okay, this is the output and final signal that we got. As you can see, we got a lot of noise for the final result. And the third figure, this is the input for our circuit, demodulator circuit, and it is the output of the modulator circuit by other groups. For the final figure, this is the full AM modulator and demodulator circuit. At the top one, we got the demodulator circuit, and the bottom one is the demodulator circuit. For our demodulator, as you can see, this is the input signal, and this is the ground. And finally, for the modification or solution that our group can implement to improve the efficiency of this demodulator circuit. Firstly, for the carrier signal stability, we can use the crystal oscillator or phase lock loop PLL for generating a stable carrier frequency for the signal. Secondly, the linear modulation, we can use a balanced modulator such as a diode bridge modulator for achieving a better signal. And finally, the component selection for our circuit, we can use a better tolerance, low frequency drift, and high frequency handling capabilities for capacitor, inductor, and the amplifier. Okay, that's all from me. Thank you.